In this video, we're going to talk about performing a significance test to compare two proportions. We've been talking about proportions. We know about significance tests. Okay, so obviously if we're going to do significance tests, we need a null hypothesis, which would be that p sub 1 minus p sub 2 is equal to 0. That's the way I prefer to write it. Some people write it p sub 1 equals p sub 2. Either way is acceptable. Okay. And then our alternative hypothesis is going to be one of three things. P sub 1 minus P sub 2 is not equal to 0, or P sub 1 minus P sub 2 is greater than 0, or P sub 1 minus P sub 2 is less than 0. Okay? And as we had with our confidence interval, the conditions are random, 10%, and large counts for both populations. Okay, we've beaten those pretty good over the head, and so we don't need to continue going over those. We know what those conditions are. So we want to do a two-sample z-test for the difference between two proportions. So this goes back to what we know with our test statistic. Okay, we know that it's equal to the statistic minus the parameter divided by standard deviation of the statistic. Okay. This one gets pretty complicated the way that it looks, and there's lots of chances to make mistakes. Okay, we would have to have what's called the p hat c, which is combined, and that would be x1 plus x2, the number of successes from both populations added together, divided by the sample size from both populations added together. And we use that to calculate our test statistic. So our test statistic would look like this: p hat 1 minus p hat 2 minus 0. Minus 0 because that's what our null hypothesis is, that it's going to be, there's going to be no difference. Okay? And then divided by the square root of p hat c, p hat combined times 1 minus p hat combined, divided by n1 plus p hat combined times 1 minus p hat combined, divided by n2. Okay? Now, I would suggest that we have the technology, we use it. There's a lot of chances to make calculation errors when you try to do this by hand. Okay, so on the calculator, we're going to do it this way. It's stat. Okay, then you go over to tests, and it's number 6, 2 prop z test. Okay, and put it on your paper like this: 2 prop z test, and you're going to give them x1, n1, x2, and n2, and you're going to report out your z, your test statistic z, and your p-value every time. That's the way I would suggest that you go, because there are lots of chances to make mistakes here. So let's take advantage of the technology while we have it. Okay? Now, so are teenagers going deaf? In a study of 3,000 randomly selected teenagers in 1988 to 1994, 15 showed some hearing loss. In a similar study of 1,800 teenagers in 2005-2006, 19.5% showed some hearing loss. Okay? Do these data give convincing evidence that the proportion of all teens with hearing loss has increased? Okay? So state the hypothesis we are interested in testing. Define any parameters. Well, our null hypothesis is the same. P1 minus P2 is equal 0. There's no difference. The no difference hypothesis, that's the null hypothesis. And then the alternative hypothesis, that P1 minus P2, it's increased, so that difference would be greater than 0. And that's if we use P1 being the teen proportion of hearing loss in 2005 and 6. And then P2 would be the teen proportion of hearing loss in 1998 or 1988 to 1994. So we've defined our parameters, we've set it up. All right. So the same problem. Now they want us to ask if they give us convincing evidence. Do these data give convincing evidence that the proportion of all teens with hearing loss has increased? Okay, so we have to do a significance test. And then after that, it says between the two studies, Apple introduced the iPod. If the results of the test are statistically significant, can we blame iPods for the increased hearing loss in teenagers? So we have two questions to answer. So the first one, as always, if conditions are met, we will perform a two-proportion Z test. Our null hypothesis, we already wrote those. P1 is 2005 and 6 hearing loss. As we just did this a minute ago. P sub 2 is 1988 to 1994 hearing loss, and both in teens, right? I'm going to make sure we have that in teens. Okay, so we have to do our conditions. So random. Both studies chose teenagers at random. They stated it in there that they chose them randomly, and we're just restating it. 10%. In 2005 and 6, there were more than 10 times 1,800 is 18,000 teenagers. In 1988 to 1994, there were more than 10 times 3,000, 30,000 teenagers. So the 10% condition is met, so of course we can use our so we can calculate the standard deviation, large counts. So 0.195 times 1,800 equals 351. And 1 minus 0.195 times 1,800 equals 1,449. And then 0.15 times 3,000 is 450. And 1 minus 0.15 times 3,000 equals 2,550. Okay. All of these are greater than or equal to 10. All of those are greater than or equal to 10. So now we do our calculations. Okay. Two-prop z-test. And x1 which is going to be 351, and N1 is the 1800, because our P1 was proportion in 2005 and 2006. Our X2 is 450, and our N2 is 3000. That's what we put into our calculator. We're telling them that. Okay. When we put that into our calculator, we're going to turn the calculator, we'll put that in. So stat over to test, number 6, and 351, and 1800, and then 450, and 3000, and we want P1 to be greater than P2, and then we just want to calculate that. So we report out the Z, which is 4.047, so Z equals 4.047, and we also have to calculate, put out the p-value, which was 2.58 to e to the negative 5. That e to the negative 5 tells us that this p-value is essentially going to be 0. That p-value is essentially 0. Okay? So conclusions. Because our p-value equals 0 is less than our alpha level, and since they didn't give us one, we use 0.05. We reject the null hypothesis. There is convincing evidence the proportion of teens with hearing loss increased from 1988 to 94 to 2005 and 6. So that answers question A. We do our hypothesis test. Now we have to answer B. Between these two studies, Apple introduced the iPod. If the results of the test are statistically significant, which they were, can we blame iPods for increased hearing loss? Well, no. No, simply because we weren't testing what caused the hearing loss. We were only testing whether hearing loss increased. We had no way, we didn't test that. So because we didn't assign some teens to iPods and others to avoid using iPods, we can't generalize. There may be other causes. Essentially, we didn't test that. We didn't test what was causing the hearing loss. That would be a totally different test. We didn't test that.